exponents. And so we're going to deal with rational exponents. And if you don't remember what I mean when I say rational exponents, we're talking about like if we think of rational number, like a real number is just any number as a decimal ever, right? A rational number just means or rational numbers are anything that can be expressed as a fraction. So usually when we talk about like rational exponents, we're talking about fractions for exponents. So, for example, the inverse of squaring a number is to find the square root of that number. And the inverse of cubing a number is to take the cube root, etc., right? If we did the quartic of a number, or the fourth power, we would take the fourth root, right, to undo that, right? We know that the square root undoes the square, the cube root undoes a cube. We know that. Now, here's a little terminology, right? If we have a number in here, I don't know, a, that when we say, where is the word? The radical indices or singular would be index. That's referring to the number that's here. So when we just write this, it's a square root. We kind of have an invisible 2 there, the second root. But you guys should have seen this before. We could have the cube root of a number, right, or the fourth root or the fifth root and so on. And so that'll just be some important vocab. But here's where we need probably a little reminder, or this might even be totally new. I'm not quite sure. So rational exponents, so exponents with fractions in them, correspond to radicals. So like taking the square root. So the number of the numerator of the rational exponent is the power of the term. So if I had a, let's do my whole example. If I had a number a, let's make this whole example out of a to the 3/5, right? That's a fraction. So the number in the numerator of the rational exponent is the power of the term. So a is our term, so we're going to have a to the third. The denominator of the exponent corresponds to the index of the radical. So the denominator, the 5, is the index of the radical. Oops, why did it give me that? So we're going to do our radical. And now the index is 5. So we're taking the fifth root of a cubed. That's what a to the 3/5 means. And then when written in rational form, the exponents can simplify according to fraction rules. So if I had a to the 4/6, right, that's really the sixth root of a to the 4th. That can be written as a to the 2/3. Right, so you can reduce those fractions. Okay. So we just have a few examples to get through today. We have one more slide after this. Use radical notation to rewrite each exponential expression. So 5 to the 1/2 is 5 to the first, right? Which anything to the first is just itself, and then we can take the square root. So to the 1/2 really just means square root, right? And we don't have to write the 2 as the index here because when we write the square root, that 2 is implied. Now for this one, this means we'll have the cube root of x squared, right? So x to the top power, and the index is the denominator. And here, if you have something in parentheses, you do it to the whole thing. So here we would do 7x cubed, the fourth root, but we can simplify that a little further, right? We can do 7x cubed. That's 7 cubed and x cubed. 7 cubed, what is 7 cubed? 7 cubed 343. So this will be 343 x cubed, the fourth root of 343 x cubed. And then here we have 6y to the 5 halves. Again, here's where you have to be careful of where, like, what your exponent is actually attached to. This 6 does not have an exponent on it, so this 6 just stays a 6. But this y is to the 5 halves, or the square root of y to the 5th. Right? And again, when it's a square root, we don't have to write it because it's implied that the 2 is here when we do a square root. And so for our other examples, now we're going the other way. We have to write them in exponential notation. So the cube root of x squared, we're going to do x and then to the power over the index. So to the 2 divided by 3. This one is going to be the whole thing, 3y to the 1/2. Right? And if you want to, you could write 3 to the 1/2, y to the 1/2, both the same thing. Right here, this 8 is all by itself, right? The 8 has nothing to do with anything under the radical, so the 8 just stays an 8, and we can write that x as x to the 2/5. And then this square root of 7, 7m to the 5th, again, it's that whole thing to the 5th. But here's what I would do, right? Here we have the square root of 7m, which in fractions, that'd be 7m to the 1/2, right? That's the same thing as this. And then that is to the 5th. So what we really have, remember, exponents to exponents, you multiply, we have 7m to the 5 halves is what we really have there. So that might be a bit of a tricky one. Okay, and that should be, yep, that's it. So does anyone have any questions on radical or rational exponents? It's just kind of something you have to memorize, that the top one is to the power. Otherwise, also another way to do this one. This is just how I happen to think about this one. But really, you can go in any order, right? So this whole thing square rooted, you could automatically just say, okay, well, that's to the 5th, right? And then the square root is over 2. You could go to that. I personally like to think, I like to think almost like left to right, like logically. The first thing I see is 7m and a square root by itself, so I like to put it as 1/2 to the 5th. But you could go straight here, because it doesn't matter if you have the square root and then it's to the 5th after, right? Or even if you had a cube root to the 5th after, then it would just be 5/3.